video, we will show you how to use lidar sensor in Arena building toolkits. So lidar sensor is already built as a prefab in the Arena SDK prefabs. So all you need to do is to drag this lidar sensor prefab as a child of your agent. So here this is basic agent and it's Arena agent. So here the lidar sensor is the child of this Arena agent. And if you do not want to use it, you can just disable it. When you enable this lidar sensor, the Arena agent prefab will automatically detect all the lidar sensor that is attached as a child of itself and collect all the lidar data from these lidar sensors to form to uh, put them together and make it the vector observation of this agent. So let's see the parameters in the lidar sensor we can use. Here in the editor, there's already a preview of the lidar sensor. So basically, the right lines means that the lidar sensor does not detect anything, and the green lines means that the lidar sensor is detecting something, and the length of this green line means the distance between the lidar sensor, between the start points and the detecting points. So you can move this agent around so you can see the change of the lidar sensor. And let's see the parameter of this lidar sensor. Basically, you can select if you want it to be visualized in your editor. And also you can select this lidar sensor is a general lidar sensor that supports two-dimensional lidar, which means for now it only has one dimension at this around this axis. And so when you look the lidar sensor from this side, there's only one line. Whenever if you put two of it here, you'll see it becomes a two-dimensional lidar. And the next two parameters are the field of view on both dimensions. So you can change the field of view like this. And then this parameter is scan frame per second. So basically in practice, the lidar sense cannot just spin fast enough so that it can collect all the data from so that it can refresh all the data in every direction at each frame. So basically, you can set this parameter so that it uh, fits it more like the real-world practice case, where part of the data from the lidar sensor is delayed. So let's try see how this parameter works, so that you can understand why we are having this parameter. So here, when you set this parameter to -1, it means that the lidar sensor is scan the whole space all the time. At each frame, all the data points, all the 84 data points will be refreshed. And you'll see it actually, in this case, it will cause the sensor to runs a little bit slow because you are getting all the data points at each frame. However, when you set this value to some positive value, see I only want the whole frame to be scanned for once in each second when I run this game. Here see it shows the part of this lidar sensor that is being scanned. So let's just make it more clear when you set this value to very small value. So basically lidar is just sample one data set, sample one data point at each step. So I believe when you change to change this, we believe that changing this parameter will make your lidar sensor more like the one in the real world. And there's another few parameters in the inner bound. So basically, it means that for the object that is within the inner bound of this lidar sensor, it will not be detected. This when you move this value, you will see the lidar sensor starts from an offset points around the center. And also, in some practical case, you may want to put your lidar sensor like not in the middle of your agent, say on the top, on the left. It all depends on you. You can just move this lidar sensor around. And for the perimeter of outer bound, it means that all the objects that is outside this outer bound will not be detected by the lidar sensor. So these are all just what happened in the practical case when your lidar sensor has a limitation of minimal detecting range and a maximal detecting range.